Hello everyone. Have you ever wondered how all the elements in the universe found their place on a one table? It's a really fascinating journey of discovery. So welcome to ChemSquad, and today we are diving into the story and the science of the periodic table. Alright, let's start from the history. So many scientists contributed in the creation of the periodic table. It's like John Dobereiner, John Newlands, Dmitri Mendeleev, Antoine Lavoisier, Lothar Meyer, and finally the Henry Moseley. So what this John Dobereiner did was he grouped elements into triads. Triads means set of three elements based on similar properties and noticing patterns in their atomic masses. Then John Newlands he proposed the law of octaves and stating that every eighth element has similar properties when elements were arranged by increasing atomic mass. And Dmitry Mendeleev also arranged elements according to the increasing atomic mass, and he left gaps for undiscovered elements. So Dmitry Mendeleev also didn't have any idea about this atomic number. He also focused on the atomic mass. Then later, the Antoine Lavoisier he classified elements into metals, nonmetals, and gases, and laying the foundation for the later periodic classification. And then Lothar Meyer, he finally means he developed this idea of the Mendeleevs and he showed that there is a connection between the atomic volume and atomic mass. And Henry Moseley was the first person to discover the concept of this atomic number, and he was the one who reorganized this periodic table based on the increasing atomic number instead of the atomic mass. This periodic table was evolved into what it is now. So now we call it as the modern periodic table. Now let's talk more about this modern periodic table. So actually, in that the elements are arranged horizontally in order of increasing atomic number. So in this diagram you can clearly observe how these elements are arranged according to the increasing order of their atomic number. So you can see that how this atomic number was placed, and also each element is identified by its symbols placed at the middle of the square. The atomic number and the atomic mass, so mass number, are also included. So that means in here you can observe how this atomic mass and the atomic number, and this is how the symbols are given for the each element. So each element in the periodic table. So this is how they all these are arranged within a square. Can you tell me how many elements are found within this periodic table? It's actually 118 elements are found in the modern periodic table. In that, the first 94 elements are naturally occurring elements, and the remaining 24 elements are synthetic and they were created in laboratories. So that's how these 118 elements were created in the periodic table and was included to the periodic table. Now, let's talk about the arrangement of this periodic table. So this periodic table is having 18 vertical columns and they are called as groups, also known as families. So it composed of two categories. So one is group A and the other one is group B. So I want you guys to know that this grouping system was changed by the International Union of Pure and Applied Chemistry in 1995. And they gave a numbering system rather than this A and B classification. So, but I'm including this classification because this makes for you guys to identify this each group clearly. So, according to that, this group A is include alkali metals. So this group A elements we called as the representative elements and group B elements we call them as transition metals. So this is how they were categorized these two group A and group B. And this is actually the modern classification of the groups. So where we call them as the columns and they were numbered up from 1 to 18. And then this is how this group A classification was done. So there are alkaline metals, alkaline earth metals, aluminium group, carbon family, nitrogen family, chalcogens, halogens, and finally the noble gases. And these are the elements that belong to each category. That means alkali metals. So these are the elements that include in the alkali metals: lithium, sodium, potassium, rubidium, cesium, francium. And the elements belong to the alkaline earth metals are the beryllium, magnesium, calcium, strontium, barium, and radium. And from this, halogens and noble gases are very much important. So the elements that belongs to halogen are the fluorine, chlorine, bromine, iodine, astatine, and tennessine. And the elements belong to noble gases are helium, neon, argon, krypton, xenon, and radon. So these are the elements that belong to noble gases. Now let's talk about group B. So group B, it is found between the group 2A and group 3A. So group 2A and group 3A. So the group B is also referred to as the D block. And the inner transition elements, they are found at the bottom of the table and it is referred to as F block. So what are actually these transition elements and the inner transition elements, and what actually the difference between these two? So the transition element means these are the elements in the middle of the periodic table with the electron filling up to d orbital. So they are often colorful compounds and they are good conductors of heat and electricity. And for the inner transition elements, these elements are located at the bottom of the periodic table with electron filling up to f orbital. And they includes the rare earth elements like lanthanides and the radioactive elements like actinides. So this d orbital, f orbital, like these orbitals, they included to the means electronic configuration thing, and I'm not going to explain it in this video because I will explain it in a separate video. And for now, just get an idea that this transition elements, the electron filling is up to d orbital, but for the inner transition element, they are having the electron filling up to f orbital. All right. Now, now let's talk about another important arrangement in the periodic table. So actually, they are called as periods or also known as the series in the periodic table. So actually there are 7 horizontal rows. So this is how these periods are arranged in the periodic table. And this is the first period, second period, third period, fourth, fifth, sixth, and there are periods up to 7. Alright, now let's talk about how metals, nonmetals, and metalloids are arranged within these periods. So this is how these elements are arranged. So actually the things which are in blue, they all are metals, and the ones which are in red color, they are non-metals, and the ones which are in green color, they are metalloids. So I will explain what are metals, non-metals, and metalloids separately. So, so actually why we need to identify these metals, nonmetals, and metalloids? So the reason is because these elements play a crucial role in our daily lives. So these each and every element is very much important for various industries. So that's why we need to identify whether this is a metal or non-metal or metalloid. Metalloid means they show both metallic and non-metallic properties. So now let's talk about some physical and chemical properties of these metals, nonmetals, and metalloids. So here it is. So the metals, they are having some physical properties like malleability, ductility, and they are good conductors, and they are having a very shiny appearance, so which we call it as the lustrous. So malleability means they can be hammered into thin sheets. That means, for example, if we take iron, so iron is a metal, so it can be hammered into a very thin sheet. And conductivity means it can be drawn into wires. And then the next one is good conductors. So the metals are excellent conductors of heat and electricity. Examples we can take copper, which is widely used in electrical wirings, and also we can take aluminium. It is lightweight and it is used for the electrical transmission. So all these are good examples for the metals. Now let's talk about physical properties of nonmetals. So nonmetals, they are having some properties like brittleness, softness, and they are pure conductors, and they are poor conductors, and they are non-lustrous. So actually, so brittle means Brittleness means they breaks easily. For example, we can take sulfur. And like poor conductors means they do not conduct heat or electricity well. For example, we can take carbon as graphite. And non-lustrous means, for example, we can take phosphorus, and it is having a dull appearance. And then when we talk about metalloids, so they are actually, they can be malleable or they can be ductile because they show both metallic and non-metallic properties. And the most important thing is like they are semiconductors because they can conduct electricity under certain conditions. Example, we can take silicon, and then it can either have a shiny appearance or else they can have a dull appearance because of their metallic and non-metallic nature. This happens. For example, we can take boron, and also they having this brittleness nature means they can break like non-metals. Example, we can take arsenic. So this is how the physical properties of each metallic, non-metallic, and metalloids vary from each other. Now let's talk about their chemical properties. So actually, metals are having the tendency to lose electrons and to form cations. And also they can form oxides by react with oxygen. And the other thing is they produce salt and hydrogen gas by reacting with acids. For the nonmetals, the tendency to gain or share electrons is actually for the nonmetals, they gain electrons, right? And also the other thing is like they can form acidic or neutral oxides with oxygen. And when we talk about metalloids, because of their metallic and non-metallic nature, so it depends on the element for how they react. And they can form amphoteric or weakly acidic oxides. So amphoteric means it means a substance that can act as both an acid or a base in a chemical reaction. For example, we can take aluminium hydroxide. So it reacts with acids and bases. So that is how this amphoteric nature comes for the metalloids. So actually, when we talk about this periodic table, so it's more than just a chart. And what we discussed today is only the basics, and but there are so much more to uncover. And in our next video, we will talk some more stuffs regarding these old things like periodic trends, means electronegativity, ionization, everything. And don't forget to subscribe and stay tuned for the next episode.